Okay, so it looks like we're going to use this little guy here. I remember the signal tracer that I kind of kit that I built and put in this box. We'll use that a little bit and see if we can narrow down what's going on with this radio. It's intermittent. Sometimes it works, sometimes it doesn't. Maybe I'm breaking more than I'm fixing. So we'll get through this together, hopefully. There's going to be a lot of what do I want to say? A lot of book work in this. So we'll be using the schematics and the books a lot to try and troubleshoot this. So this may be kind of boring, and I know I haven't done a video in a while between winter and horses and sicknesses and everything else. I just haven't had a chance to get down here, and I have made a couple, but just nothing that good. Nothing as exciting as this. So let's get to it. All right, so I'm going to pump a signal into it. And I think this is, I can pick this one up. That's right at the antenna jack. That's what I'm picking up. So then we'll go to the RF amplifier, first thing in the chain, and it's Q114. All right, let's see how this works. So the signal comes in. You can see I have it pasted or outlined in green. And the signal comes in through J1, and it goes up here, goes all the way around. Now, I don't know if this is going to go away when I do this. Continuing to follow the green. See if I can zoom in a little bit. There. Goes through the filter right here and follows this line down here, shoots all the way across to the board. And where are we? Here it comes down here. Keep on going, keep on going. Gee whiz, that goes all the way across the board. All right. And here is the input. You can see the first transistor here is the RF amp. It's Q114. And we will look at the collector of Q114. Oh, I think I can turn that down considerably. Let me turn the volume on this down first. Q114 collector. Let me turn this up. Amplitude. All right, so that's, now we're at minus 43. So we got past that. Who's next, Johnny? Let's see. It's probably, I'm sure it's in the PLL circuit, but we're going to double check. Let's see, where were we? RF amp. We'll come on, let's look at like the second mixer. Just got to jump in a couple stages. So that's Q116. All right, so moving right over to Q116, as you can see here, we have Q115, which is the first mixer. But you'll notice there's a blue line I have highlighted coming down. And if you follow that blue line goes up to a buffer. And the buffer is separating the VCO. So this is going to be part of the PLL output. Basically the voltage controlled oscillator. It takes the place of the crystals and everything. So we have the buffer to contend with. We have to think about that. So the buffer gets introduced to the green signal, which is your input. That's in Q115. And that produces a different frequency. And that feeds into Q116. And if you'll notice, there's another color line there. And where does that come from? All right, Q116. You have to take into consideration now the 1024 megahertz reference oscillator. So that's getting introduced there. And I want that collector. I know I saw 116 in here somewhere. There's 15, 122. All right. 106. 118. All right, let's check the collector then on 115 because I can't find base, emitter. There's a collector probably right there. Oh yeah. See, its signal got higher. We're gonna go. So let's find our. Well, let's see if we can skip a couple more. That was. We could look at. And I found 18, so we could find 18's collector. All right. Well, the signal continues on here past the 116, which I didn't find to check. But you'll notice here this crystal filter before it gets to the Q118. And that crystal filter is going to kind of be working on the IF frequency. So it's going to be contingent on everything being right on to get through that crystal filter. There's 118. I think I just saw it on here somewhere. Right there. Here's its collector. I'm going to poop the ground where it just popped off. All right, we got awful quiet again there. Let's look at its base and see what it's got going into it. Got nothing going in, it doesn't look like. But that isn't necessarily a good test. So what are you at? 118. Let's find 116. Gotta be around here somewhere. Q16, here we go. Let's look at its collector. Alright, so we have a really good signal going in there. Let me turn this up. Alright, let me just turn this down then so I don't want to hear that. Alright, so that's going into, what did I say, 116. That's the second receive mixer. So it comes out of there through a crystal filter, CF101. And I should get it at the base of 118. Is this 118? Sure looks like it. If I can get anything at the base here. Here's the base. Okay, so what we have going on here is I finally did find Q116, and I had a decent signal coming out of Q116, but almost nothing going into Q118. And here's this crystal filter I spoke about earlier. Now that's the one that sets the IF frequency. It passes everything at 455 kilohertz. Well, the problem is with this is since not everything's lining up, obviously something's wrong with either the signal coming in or with the VFO signal here or with the 10240 signal. But they're not all jiving up to beat 455. And you can hear how weak the signal gets on the other side of this. In fact, I think I had to really turn it up to hear anything at all. And then we'll find out something even more interesting. No matter what channel I'm on or what frequency I'm pumping into it, as long as it's somewhat close, it
changing the channel doesn't affect it. So we'll see that next.
Oops. Didn't want that frequency. That's kind of interesting. Okay, I wanted to take a look at the switch and clean it. And it had this little black cover on the back of it. And I just popped it off with a screwdriver. And there's the switch in there. It's a little more intricate, but it's got a bunch of contacts. So I'll just spray some contact cleaner in there and see what happens. We'll see if that changes our outlook. Again, I'm just using contact cleaner and not even anything like the oxide or anything. All right, we're on channel 1, and we wanted to test our DC voltage at. Now let's see what we're doing here. At test point 8, which is R114. Where were you at here? Here we go. We were looking for 1.5. We got 1.45. That's pretty darn close. Then we went to the blank spot. It should have been between 5 and 5.5, 5.3. Now I went into 23. 22. 23 staying that. All right, so 23 is staying that high. If I rock the switch a little, no, it's not even the switch. So I want to see. I'm going to pop this off, the contacts back here that I just squirted with contact cleaner. And take a look. So it comes on. Here's the contacts. The multi-contacts are at the bottom. You can see the contacts on it, how they're made. And then if you look at the board, there, you can see how that's the back of the switch. That's how that looks. And then this one on probably goes on one of two ways. So I just kind of made a note that the multiple contacts were toward the bottom. Okay, so my problems continued, and I think there's a front half to this switch that I cleaned, and because it seemed like things had changed after I did the cleaning. I don't know if I can get to it from here. So anyhow, I'm going to take the front panel off here, and we'll take a better look at it. So let me get this all disconnected so we don't fry anything. That's off, and get our ground lugs off. Get this speaker out of our way. And let's see if I need a better screwdriver than that. All right, so I got this apart, kind of. There's one screw in here. They use this lock thread. I've never seen lock thread, like industrial strength lock thread like this before in my life. So let's see. All the tangies are on the upside here. Hopefully I can get this out, or at least here's the switch I'm working on. It's inside here. Looks pretty much just like the one I took off the other side to clean it. But yeah, I got all the screws out, but the one, it is literally, I'm going to have to use vice grips to get it out. I've never seen lock thread like that. It came like 3/4 of the way out. And it just will not come out the rest of the way. It's destroying the screw head, that's why. But let's see in here. All right, so that's what it looks like in there, the switch. But that does not want to come off of there. So I'll have to clean it while it's on there. So I don't know if you can see that. Try and that's what it looks like. And one of these tangs on the edge is kind of bent. Alrighty, so in case you didn't catch that, it's working real intermittent, and I'm kind of getting drawn. Right now, I'm not getting any signal. Sometimes I get something on channel 1, but I'm kind of thinking it's going to be in the PLL circuit. So we can learn this together. I mean, I remember them from books, and never really played this as a PLL integrated circuit. So, all right, so here we go with the PLL circuit, and it's pretty much going to just be this red area, the area in the red box right here. And you'll see I have two other things in red boxes, and this one here on the left is the channel switch, and on the right is the PLL circuit. It's one IC chip, and it is a PLL02A, which apparently is a pretty common one, especially for the CBs. But this is our main concern, is going to be in this area. This is the PLL area, but here, over here a little bit further, is the 1024 reference oscillator. So I think let's first check the IC chip, and let's see what all these pins do, and we'll check the voltage to it. I did want to add here too, if you're working on these radios, or any radio for that matter, don't overlook the block diagram. They give you a lot of good information, and it's kind of like a little cheater. It tells you what's what. A lot of times these things aren't labeled on the schematic, so you're like, oh, Q102, what's that? Well, it's the mixer. But anyhow, these are always good to see. But as you can see, they did the same thing here as I did, and they blocked off the buffer, or the PLL circuit. So this is where we'll be mainly training our thoughts. All right, that's my public service announcement for today. All right, I made my own cheat sheet sort of thing up here from a couple different resources, and the one here on the left, it tells you what the pins are, the 16 pins, and real quick, you have, of course, your power supply. Then you have the input from the VCO, which is the channel selector section kind of deal. But let me rephrase that. It's not the channel. It's the frequency that you'll be tuning to. It uses an input from that. It's not going to be the exact frequency, but it uses an input from that, and that comes into the PLL, and it compares it to what
you have pretty much entered into the PLL as an input, and that's where these binary inputs all come into play, the 7 through 15. But so it's just kind of the comparator input, and we'll cover that later. But next thing you have is the reference oscillator, and that's that 10240 crystal. Right here, it's how you have the PLL configured for high or low. That's not something we change. That's something that they change on the design. That's something they change on the design of the circuit. So we just go with what they tell us that should be. The next is the voltage output, and that would go to the VCO to change it. There's a little circuit that changes the frequency at the VCO. Next is the loop detector, and that tells you that's an output that tells the rest of the radio whether it's locked or not. And by locked, I just mean that it's on frequency. And then these inputs, all the binary inputs, they're the inputs from the channel selector switch that tell it what channel to expect. So we can go into that later. And this right here is the chart from the book that tells us what the voltages should be. So when I go to test the the IC101, the PLL chip, pin 1, I get supply voltage, pin 2, 3, and let's see, 4, I get pretty much something within that ballpark. 5 seems to be a little bit on the high side. So let's see, 6, 7, 8, and 9, and 10. They don't much matter, but I'll show you on the chart. So here we have 11, 12, 13, 14, and 15. Of course, 16 will be the ground. So these all check correct except for 1. And I kind of made so it's easier to follow, I made a spreadsheet with it. So let's get to that spreadsheet and we'll see what we're looking at. It's right here. So it tells you that these pins, pins 7 through 15, they kind of come up and they'll end up equaling a certain amount that we can equate to a frequency. So pin 7 is probably not used because right here it tells you pin 7, 0. So pin 7's tied low, so we're not worried about that. Then it tells you that pins 8, 9, and 10 are all tied high, 8, 9, and 10. And then it tells you that pin 11 on these select channels should be high. On the other channels that aren't listed should be low. Same thing with 12, 13, blah, blah, blah. So anyhow, I made a little chart here. And then I just summed up what my findings were. And if you see, I get a nice order of 2240, 2256. I'm not going to read them all because you can. And 70 seems to be missing. 80, 90. And it goes 70 is always missing. But if you notice on the CB channels, they're not always just 10 away. So anyhow, there was a mistake though in here. This threw me off for a while. I kept looking. I was going back and forth until I actually plotted it. So it'd be pin 12, and that's going to be for CB channel 11, I think. Yeah, for CB channel 11, they're telling me that on pin 12 it shouldn't be turned on. You see, I even left it black because that's what they're saying, or shaded rather. No, I'm sorry, that's pin 12. So let's see, 12. Yeah, so pin 12. So 8, 9, 10, blank, 12, 13, 14. And when I was doing my testing, it kept showing that it was turned on. So that's why I was thinking, well, it must be the switch's fault. However, when I do this math, and I find, and you'll see these numbers where they kind of fall into place, I'll show you in a minute. These numbers are pretty much equivalent to what we would be seeing through the coming in from the VFO. So it actually compares it. It's like a comparator. So the voltage, or the frequency rather, coming in from the VFO gets compared to what the PLL is seeing. And if it doesn't see the right voltage, it sends, if it doesn't see the right frequency, it sends a voltage either positive or negative to the VCO, the voltage controlled oscillator. There's a varactor there, which is looks like a diode, but it acts kind of like a capacitor, and that's part of the tuned circuit. So that can change the frequency. So it's always monitoring and deciding, is that frequency on? Do I need to bring it up, bring it down? But anyhow, without this 80, if I follow the way the manual says, and we'll just do away with the 80 for a second, you can see that's 2280, and there's already a 2280 spoken for one thing, and it wouldn't be in order. So we're going to go back and put the 80 back in here, and now it's in the correct order. So I think that in the manual, well, I know in the manual this is incorrect. There should be an 11 in between the 10 and the 12. Let's see. So if you look at this 2240 through 2530, all right, looking at the block diagram here, remember those numbers, the 2240 through 2530, and if you look coming out of the PLL mixer right here, there's those numbers at 2240. Well, if you change this to kilohertz, it's 2240 to 2530, and that's the frequency going into the PLL chip, and the PLL chip will compare that to the number that is binary code into it, and it compares it, and if it needs to go up to match that or down to match that number, the frequency number, it'll send a voltage it goes through this low pass filter and then over to the voltage controlled oscillator, and it'll make that change, and it'll bring it up a little bit, down a little bit, and it keeps going through. It keeps evaluating it over and over again. So not only is it passing it through, it's also it's passing it through to the receiver and transmit components. It's also evaluating it constantly to make sure that it's on frequency, and that creates a frequency lock. Oh, here we go. Once it matches, it sends another signal out on the loop detected, and if it detects that you're in the loop, which means that it locks, then it'll send it'll send a voltage out 5 volts down the road to the rest of the components saying, hey, I'm locked, and you can go ahead and buy your business. On my particular instance, I'm not getting a high. I'm getting a low. It's not locking. On some channels, this voltage is within specs, but on most channels it's not. So I'm assuming it's something in the PLL circuit. Pretty sure it is. I'm thinking maybe capacitors, but I want to be...
All right, there you have it. Either I'm really breaking this or there's something wrong with it. So hopefully we can fix it. I don't know what's wrong, but I'm pretty sure it's in that PLL circuit because it's not getting a lock. And, you know, it certainly could be capacitors, but I'd sure like to be able to prove that and find a faulty capacitor, or at least a way that leads me to a faulty capacitor rather than just throwing all new electrolytics in it. So, if anybody has any good ideas, I'm open to it. And I don't know how durable that PLL chip is. Maybe I destroyed that. I don't know. We'll find out, and I'll just keep poking away at it. Hopefully I can get back to it pretty soon. Thanks for watching. Have fun.